That's quite an introduction. It's an even bigger introduction when I've got such a bad hangover after last night. So for all of those who were here and with me on the table last night, thanks very much for that. I appreciate that. It sounds very flash, the introduction that I've just been given, because we have all these titles and all these different things. But actually, the truth is, this gives it away. I'm analog. I'm not digital. I come from a background where we build machines, and in particular, Ecomar Propulsion, which was the business that I set up, is designed for zero-emission propulsion systems. Now, that sounds very simple, but I think it gives you a background, an understanding of where we came from, where we are at, and why we've now got this new emphasis on digitalisation. So we come very much from the basis of it's a thing, it's a tangible thing, it works. And I was a Luddite. I really didn't want to know about ones and noughts and ins and outs and all these sorts of things. That's for somebody else who's 20 years younger than me, understands all that stuff. I'm sure there's some of us in the room here, although I can't see anybody through this. But anyway, but that's where we started. And so to set Ecomar up, what I needed to do and what my team needed to do was to really interrogate what is required. And so we looked at the shipping industry, and I started with the emphasis on high-performance craft. And then we found out very quickly that that isn't going to work. I'm sure those of you who were in yesterday, there were lots of graphics up about the scale and size of batteries and hydrogen, and then you relate that back to other fuel systems, and you go all the way back to, back to diesel, basically. And you'll see that there's a difference between new fuels and old fuels, and we'll call them old fuels for simplicity's sake. So as we interrogated this whole thing, what we decided to do was to scrap everything. We go from a clean sheet of paper and say, all assumptions that currently exist no longer apply to what my company is going to do. And that gave us a really open goal. We could go out there, we could see where we should be, what questions we could answer, what value we could provide to the world, because otherwise you're setting up a business that's just a vanity project. And we ended up defining segments. And so we're very aware of the fact that currently grey ships and all those big VLCCs and so on, absolutely out of the question for us. We can't do that. But we know as an SME that the workboat sector, sub 50 metres, is absolutely perfect for what we can do. And we can deliver product, we can deliver powertrains that will suit that market, will meet those duty cycles, and will actually be cost effective. So during the whole process, we were looking at electrification. And obviously you start with batteries. We've then moved into hydrogen and all the complexities that go with that. And we're working now on methanol systems as well, because we're being asked by companies with bigger and bigger ships. The largest one we're working at the moment is 5,000 tonne, 100 metres. It's a bulk carrier. But when you see the different kinds of fuels that are available and the different choices, and these are the things that people are always talking about, constantly I'm getting, oh, hydrogen's no good for this, battery's no good for that, methanol's no good. True, there isn't a perfect answer for everybody. We cannot go back to the days of hydrocarbons. And the reason I say that is that the world is moving on. Yes, ships have got 30 years lifespan. We understand that plus. And they are a major capital investment. We understand that. But the world wants something different. The world wants clean. And we're all aware of whether you believe it or not, and whether Taylor Swift endorsed us this morning or not, doesn't really matter. The fact is that we are moving into a new world, revolutionary world, not just in terms of digital, but in terms of physical assets, the movement, and ultimately what the customer wants. Now, we're talking downstream at this point, customers, the end user, the guy who buys something made in China that's shipped across the world and comes into B&Q and you go and buy it on a Saturday afternoon. That's the customer that's driving all the choices. And everything we do in the middle as those providers has got to respond to that, because they're going to buy clean all the way through for the rest of their lives. New generations, every generation will come through. And we can be, exactly as I say, as Luddite as we want, but that's going to happen. And so I won't bore you with going over all the different things, but there are some graphics on there that are quite useful in terms of energy densities and these sorts of things that other people have talked about in great detail. I'm happy to talk about this at any point later on if you wish. But for us, the focus is on battery and hydrogen in the workboats. So if you want to challenge me on a grey ship, going out to the Gulf in 3 weeks or whatever, I can't answer that question right now. But in 10 years' time we will, maybe even quicker. So digital power management, that's what the real subject of the talk that I've got this morning is about. It boils down to one thing, it's a bigger brain. You need a bigger brain. All the stuff that the chaps have spoken about before, it's very broad reaching, it's very international, it's very interconnectivity, it's fundamentally what everybody's spoken about before is actually on land side, not on the ship. But we're looking very detailed at what happens on the ship. And we're talking about control systems. We're talking about how that ship operates minute by minute, second by second, what energy it's using, how effective it is. And what we used to do, or what we still do, to be honest, is the skipper's in control. And so he should be. And the skipper should be able to make those decisions based on experience and training and techniques and knowledge of his vessel and all those things. And that's absolutely, without a doubt, the right way to go. But within that, the skipper's not in control, or even the engineer's not in control of exact RPMs, exact injection of fuel, exact injection of energy throughout the system. And this is what we're looking at. We're looking at digitization and understanding and maximizing efficiency right across the piece. So we have a finite resource, and we're very aware of it, a finite resource of hydrogen, which then becomes electricity, or batteries, which becomes electricity again. All those different things that you are very familiar with need managing, and we need to manage those down to the watt or below. And we can do that now. That's the first time it's ever been possible. All those interconnectivities, all that reactive coding, all the stuff that the guys are really good at, and I'm absolutely useless at, ones and noughts and all that stuff, it makes a difference. And it makes a brain on your ship. And the brain on your ship really is there for the economy. It's moving that side, as far as we're concerned, from analog to digital. So when you turn the throttle, you put the throttle down, it isn't just a response that opens up some valves and some injectors and pumps and all that stuff. It's a response that is calibrated towards what the ship's capable of, what the energy reserves are capable of, what the sea state is, what the wind conditions are, what the objectives are, all that kind of stuff. Big brain. And that brings in value in operational and capital cost. So I'll go back to this. This is the big question, the question that constantly comes up. What is the best? What fuel should I be using? Why should I transition? What am I doing? It's really simple. We've spent years working on this. And basically, it's time to stop mucking about with this. It's time to stop making these decisions that are based on, well, I really prefer this, I really like this. Stop. Enough. Small vessels work really well, and they do work really well, and they will continue to work in existing duty cycles. They'll deliver what you need them to do on battery, possibly methanol, but usually battery and hydrogen as a combination. You put that together, you have a cost-effective solution. It means that ports can put the infrastructure in, the vessel builders can do all the stuff, and the people like us, we can do all our stuff. And then we have an ecosystem that works, and I don't like that word ecosystem, but it works for all of us, right? We know where we are, we know where we stand. Those kinds of vessels use that kind of fuel. Larger ships, and you look at Maersk and all those other guys, they are throwing billions at methanol, and quite right. Methanol has big advantages. We can pump it. It's not as combustible in normal situations as the other stuff. It's not toxic in quite the same degree. Methanol has real advantages, and we think it's perfect given where we are. We're not talking about changing the world, although we'd like to, but do the doable. If we do the doable, these are possible. And for us at Ecomar, ammonia is off. We can't do it. We can't deal with the toxicity and all the massive capital investments. We're an SME. We've got to know how to cut a cloth and how to do what we can do, and we do it well. I've got to say, we do it well. So that's basically the summation, and I hope that slide, if you interrogate it yourselves, and don't take my word for it, do your own research, you'll come to the same conclusions, I will promise you. We've spent years at this, and it's that simple. Now, when we get into the digital side of things, the guys have said before, garbage in, garbage out. It's a very complex system. This is an example of on-vessel inputs at a very top level. Each one of those could probably have 1,000 lines, sublines, and each one of those 1,000 lines interacts with the other one. So you get into this massive morass of complexity and confusion and not knowing what's what. So you have to be very clear about what the question is you're asking the machine to do and what the question or what the solution is that you need to get out the end of it. And I heard something really interesting yesterday. Some of you may already know this about the paperclip philosophy, which is a Cambridge philosopher came up with this concept, and he said, right, we've got a brilliant AI machine. It's the cleverest thing in the world, and we're going to task it with one thing and see what it does. It's a very theoretical thing, so don't worry about this. But the machine was tasked with making paper clips. as efficiently as possible and giving complete access to the world and the internet. So off it went and started making paperclips. And then it decided, well, actually, do you know what? Problem one I've got is resource. Where do I get the steel from? The steel coming into my plant every day, but it's not in the form that I use it. It's the trucks. So I'm going to use all the trucks. So it sequestered all the trucks, and then it sequestered all the cars, and it made more and more paperclips. And then it realized that, humans use most of the earth for growing food or living on. Well, that's a waste of energy because it doesn't achieve my objective. And so it started cutting all the humans out and using it all for solar powers to provide more plants. And you see the network. And in the end, everything died in the world, but we had more paperclips than you could possibly ever use. And the point of the exercise, that theoretical exercise, is that by the time you get to the end, the question you ask at the beginning may be the wrong question. And so it's really important right now that we as an industry ask the right questions. What is it that we want to do? And again, with all these things, duty cycles responding to variable conditions, that applies right across to everything. And one of the questions I would posit to you guys is, are you making decisions based on experience? Are you making decisions based on now? Are you making decisions based on your customers? And most importantly of all, I think, as an SME and what we hope to be as a challenger, are you stopping yourselves because of your own concerns about stranded assets, about resources you've invested billions in? Is this the only way we can go? And on the grey ship side of things, they'll say, a capital ship does a certain thing, but the change is happening so quickly, and the digitalisation of the world is happening so quickly. If you look at Ukraine, they're blowing up capital ships with skidoos. You know, we really, really, really have got to get to grips with this, and we're not doing. 20th century's thinking, in the 21st century and forward, it won't cut the mustard anymore. We'll be left behind. So that's a very dense slide. Very dense slides are really boring. You give a lecture, everybody switches off, they all go to sleep. Most of you want to have a coffee. I'm the last guy talking. I'm not going to keep going. But I think one of the things that I would like to bring out, optimization, integration. I'll come back to the theme now, which is digital power management. We're trying to get electrification and hydrogen fuel cells and hydrogen storage and methanol onto ships. All of these have massive complexity really embedded into it. And from my perspective as a hardware guy, a bloke who likes ships, and I'm not really interested in anything that's digital unless it does something good for me, it was a really big decision to move on. But what we've done is we've discovered that Ecomar Propulsion, the mech engine, electrical engineers, and everybody that I work with on a day-to-day basis and have done for years, have a really, really clear set of skills. And we were lacking. We did not understand, and we could not find off-the-shelf solutions for the complexities that we needed to deal with. We're talking about actuated valves in a hydrogen system that then comply with a fuel cell that doesn't have any kind of AIP or type approval and so on. So we have this huge network of things that we have to deal with. And so as a CEO, the decision I made was we have to segregate. And we segregate for one reason, that we have specializations that can work really well in one thing, team up with somebody else, and everything will work out perfectly. What we're trying to do is to make those areas, skill sets, broadly applicable. And so we created Ecomar Systems, Ecosys we call it. This is a very top-level overview. The investment that we're making is as significant as we can possibly do within our resources. And if anybody's got loads of money, by the way, I'm quite willing to talk to you about that. But I think the main thing to understand from this is that on the left side, we have what we call the VCU. This will go into production next year, and it's going through testing right now. The VCU is the nuts and bolts of it. It's the vessel control unit. That's the thing we've spent years working on, where we can get all these responses to all those previous data inputs, and it will work. And we will calibrate that, and we'll make sure that that will work. The next stage is the ICS, the Intelligent Control System. Everybody's got TLAs. For those of you in the Army, a TLA is a three-letter acronym. So the ICS is the Intelligent Control System. Now that's built to be compliant with existing networks, just as the chaps talked about. So it's a plug-and-play system. And the idea is that you will have a ship that is zero emissions or very low emissions that will operate exactly as you'd expect, throttle down, throttle back, so on and so forth. But the next bit for us, again, this has opened up a whole new world for us, a whole new world of development. I can see probably the next 5 to 6 years worth of R&D going into this. We're looking at all these data lakes and all these other things, and computer guys have got some really, really cool terms, but none of them mean anything to me. But coming back to this, the benefits. Really, we can talk to you and bore you to death about all this stuff. But what are the benefits? Profit. For all business survives on profit. Whether it's low margin, high margin, whatever else. This stuff will make your business more profitable. It will make it easier to run. It will do all the things that everybody said. AI, integrations. You'll be able to monitor all this stuff, and you'll be able to monitor exactly how much fuel you're using, where the ship is, what state of readiness all the crew is, all these other things. So there's a whole load of stuff. But profit is your key driver, and if you don't take that on board, somebody else will. There's other stuff as well that people talk about, and we talked about yesterday. EEXI, Fuel EU, the new GHG requirements and all that sort of stuff. I know there's a lot of investment in scrubbers, and as I said before, that it's not always appropriate for every ship. But zero emissions, even if it's just import zero emissions, requires a lot of control. And that's why you need a digital fuel management system to make sure that you're not wasting fuel. I mean, a combustion motor is wasting anything up to 60% of the available energy. And yet people will say, oh, well, we only need a 1,000-litre tank for this. Well, all right, you've got 400 litres worth of energy. Do the maths and you sort of see, actually, the balance isn't quite as simple as it first appears. You can get an electric motor to be well over 90% efficient. It's a big saving in terms of its requirement. It's a big change in the assumptions that are made currently, and we all need to challenge ourselves on that. So there's a whole bunch of new stuff, AI and so on. I won't go into too much detail about all that sort of thing. Multiple engines, multiple thrusters, and so on and so forth. But we're looking at dynamic positioning systems now. We're moving from 1 to 3, so we'll have active dynamic positioning systems, all controlled in this digital manner, exactly you'd expect. If you think of a VLCC as a drone, then you're starting to get towards those ideas. That's what we're aiming for. It's a transition from the now to the future. And that's the strapline that I've been given. Controllable power at your fingertips. Sounds great, doesn't it? Honestly, if that was doable, we'd do it. But for now, our objective is to try and create something on a scale that's manageable for people that need it as quickly as possible, and to save you money and to make you money. And that's it. I thank you.